So, the rest of today is going to be about how we do derivatives and integrals with those other exponential and logarithmic functions. The big thing I hope you take out of today is these three formulas I'm going to give you are just formulas. We're going to kind of just add them into our list of things we can find derivatives of, applying product rule, chain rule, all those sorts of things to these problems. We're going to start with other logarithms. By the way, again, on like a scale of 1 to 10, how important are the other logarithms on the AP exam? Maybe like a 1.5 or a 2. The big logarithm you need to be able to find the derivative of is the natural log of x. However, they may ask a question on another log, so we do need to go through this. Here's the deal. If I want to find the derivative of log base a of x, I don't know how to do this. The only log I know how to find the derivative of right now is the natural log. Is there any way you could write this in terms of natural logs? Say it again? Oh, you mean like using that change of base formula? Yeah, that's one reason I just showed that to you. We can say this is the derivative of the natural log of x over the natural log of a. Why? Because it is our change of base formula. And actually, why don't I rewrite this as the derivative of, isn't that natural log of a just a constant? So how about I say it's 1 over the natural log of a times the natural log of x. This thing is just a constant. So, I'm going to use my constant multiplier rule, which says the derivative of this is 1 over the natural log of a times whatever the derivative of the natural log of x is. Which is what? 1 over x. That's my formula for the derivative. The derivative of log base a of x equals 1 over the natural log of a times 1 over x. By the way, by the time we're done today, you'll have 3 new formulas. This is number 1. The derivative of log base a of x is 1 over the natural log of a times 1 over x. I'm going to give you 3 examples. Y equals log base 5 of x. If I want you to find the derivative, there is nothing fancy at all. You're going to go straight into this new formula that I gave you, which says you should do 1 over the natural log of whatever the base of your log is, so 1 over the natural log of 5 times 1 over x. That's our derivative. That's the formula that will give us the slope of that log function anywhere. I feel like these are a little unsatisfying because they are not super like simplifiable or anything. Whatever. Do that. Do 1 over x ln 5. I don't really care. Any of these things will be fine. I'm really not going to be making a big deal about simplifying with these derivatives. If I ask you to do the derivative of y equals log base 4 of 2x minus 3, not quite as straightforward, because you got to use what? Chain rule. I bet you can do this though. Take the derivative of your log base 4. How? Using that new rule I just gave you. And then deal with the chain rule at the end. Getting something like that? Yeah, I'm going to put it together in one fraction. I do need to be a little careful when I do this. Is that good? I would take off on the test if you wrote your answer like that. Why? You need parentheses. You got to show that entire thing is getting multiplied by the natural log of 4 without the parentheses, just the 3x is getting multiplied. If you don't want to do that, if you want to write it something like this or whatever, fine with us. But make sure if you are putting it together, you're using parentheses where appropriate. One more. Y equals log base 3 of the square root of x minus 1. There's an easier way to do this problem besides using, well, I'm going to use chain rule anyhow, but there's something I can do first. Elena. Those properties of natural logs that we looked at also apply to regular logs. Actually, you first learned about them from regular logs rather than natural logs. This is not a calculus thing. This is like an algebra thing I'm going to do first. I'm going to take that 1/2 power and I'm going to move it out front. You don't have to, but I think your derivative is going to be easier to work with if you do that. Now I'll go do the derivative. Bless you. Honestly, if you leave it like this, I'm totally fine with that. Or well, maybe not the times 1 over there at the end, but whatever. If you do put it together, just make sure you're being good about parentheses, something like that. Guess you can say 1 over the natural log of 9 if you want, or whatever. We're not going to get hung up in the simplifying. I don't plan on making these derivatives much harder than this. Basic chain rule things. I honestly think the toughest part of everything we're doing today is just actually memorizing the formulas. You're going to see why as we move through the others, they're similar, which makes them tricky to memorize because when do I do this? We'll kind of summarize them all at the end. But this is all I want to say about logs. Any issues here? Okay, other exponential functions. Let's see here. Other exponential functions. I want to do the derivative of a to the x. I know the derivative of e to the x. A to the x, though, I don't. I can't use power rule on this because my power isn't a constant. So here's what we're going to do. I'm going to start by saying, instead of doing it like this, let's say y equals a to the x, and let's find the derivative of that. It's the same problem, just written in a different notation. Any brilliant thoughts here? Perhaps thinking about how we started class today. Not the internet part of how we started class, the math part of how we started class. Maybe flip back a page. What was that? Let's try that logarithmic differentiation process. Let's take the natural log of both sides. This is not what we're going to do in general. This is just how we're going to create our formula that we can then use. I'm going to get the natural log of y equals the natural log of a to the x. Why was that helpful? That x is moving out front. Natural log of y equals x times the natural log of a. Going to find the derivative of both sides. Derivative of the natural log of y equals derivative of x times the natural log of a. Derivative of the natural log of y, we did that a couple times already. Today that's 1 over y dy dx. On the other side, that natural log of a is a constant. So really, you're doing the derivative of a constant times x. What's the derivative? The constant, which here is just the natural log of a. Okay. dy dx equals y times the natural log of a. dy dx equals, actually I'm going to switch the order of them just to make things a little more consistent. I'm going to say that my derivative is the natural log of a times a to the x. The derivative of a to the x equals the natural log of a times a to the x. Not a 1 over the natural log, just a natural log of a. And again, it is just a formula. I would like to see if you can use that formula to find the derivative of y equals 4 to the x. And there is nothing fancy here. Truly just plug in straight to that new formula. Whoops, sorry about that. My formula says I should do the natural log of a, so the natural log of 4 times my exponential function times 4 to the x. That's it. It's a formula that would find the slope of 4 to the x anywhere. And clearly the slope of 4 to the x anywhere is not anything pretty because of that ln of 4, whatever though. Y equals 5 to the 2x cubed minus 4x. What are you going to have to use here? Did you say something? Chain rule. I still can't hear anything in general. Yes, chain rule. We're going to use chain rule here. Take your derivative of 5 raised to the. How do you do that? With the new formula that I gave you. Multiply that by the derivative of the thing inside. I think you can finish this one. Derivative of 5 raised to the I've got that thing first. By chain rule, times 6x squared minus 4. Am I good? Does anyone have a problem? You gotta stick parentheses in here. You gotta show me. Otherwise, you're just multiplying 6x squared by this thing rather than the whole thing. And I know you've been like using parentheses since forever. But I actually tend to find those issues on questions like this when they show up on the test. People just forgetting the parentheses. And that would be marked wrong on the AP exam. So just make sure they're in there. One more. Not a chain rule problem. Y equals 6 to the x times x to the 6th. I want to find the derivative here. What rule are you going to use here? Product rule. I think you can do that. Go use it. I don't really care at the end if you just leave it or if you do some factoring. But see if you can use product rule on this. First times derivative of the second plus second times derivative of the first. Then we'll do some integrals, we'll summarize, and we will be done. And we are going to get through everything. First times derivative of the second times derivative of the first. First times I'm not using any like new fancy rule on this. This is just a power rule problem. I guess what I wanted you to see with this was they look sort of similar, but you handle them in very different ways. New exponential rule, just power rule. First times derivative of the second plus second x to the 6th times derivative of the first is the natural log of 6 times 6 to the x. If you want to make it a little prettier, I guess you can take out maybe a 6 to the x and an x to the 5th. You're going to get a 6 plus x ln 6 or something. I don't care what you do, whatever. That's all I want to say about derivatives. Again, I will not be making these problems horrible. They should be basic chain rule or basic product rule things. Maybe basic quotient rule, but don't expect too much of that. Does anyone need more time with what's on the screen? Okay, last thing, integrals. Just like we didn't integrate the natural log of x, we're not integrating log base a of x. That's a much, much later in the year. Actually, we're not even going to get there because normally that would be after the AP exam, because it's not on the AP exam. But we are going to integrate a to the x. The integral of a to the x dx equals. What has a to the x as its derivative? Well, 1 over the natural log of a times a to the x plus a constant is our formula. Why? Because the derivative of a to the x is the natural log of a times a to the x, and those natural logs are going to cancel, giving you the original problem back. All you really need to know is it's a formula we're going to use. The integral of a to the x, 1 over the natural log of a times a to the x. Again, I think these formulas are very difficult to memorize because they all have a natural log of a in them, but some of them are normal, some are 1 over, some have an a to the x, we'll summarize them all at the end, but yeah, I think they're a little tough to remember. Easy one to start with. Integral of 3 to the x dx. Truly plug into your formula and you're set. One over the natural log of 3 times 3 to the x plus a constant. I'm really not thinking at all, I'm just plugging into that formula. Next, the integral of x cubed times 6x to the 4th minus 2 dx. You are not, for the rest of the day, to think about product rule, chain rule, quotient rule, any of those things. We're doing integrals, which means what's the big thing you think about there? U substitution. Oh, good. What do you think U might be? Don't overthink this one. X to the 4th minus 2, so Sophia, what's du going to be? 4x to the 3rd dx. I bet you can make that work. I just don't know anymore. I bet you can make that work. See if you can multiply inside, multiply outside, and integrate this. Inside I'll stick a 4, outside I'm sticking a 1/4. So I can make it 1/4 times the integral of 6 to the u du. Keep going. Also, don't expect these u substitution problems to be super duper complicated. I'm going to keep these pretty straightforward. See if you can get my answer. If you really felt like it, of course, you can move the 4 into a power. I'm not doing that by hand. I'm just going to leave it. I guess you could also stick this thing on the top of your fraction. Whatever. One more integral. Let's do the integral of the secant squared of x times 2 to the tangent of x dx. And I think I'm just going to leave you to try this one on your own. Secant squared of x times 2 tan x dx. And if you are starting to do some complicated product rule or something, stop. Don't do that. Did you make u just the tangent of x? You should have. And I think I was pretty nice in how I set this one up because its derivative shows up exactly as is. Secant squared x dx is there. This problem is really just the integral of 2 to the u du. What is it? It's 1 over the natural log of 2 times 2 to the u plus a constant. 1 over the natural log of 2 times 2 to the tan x plus c. I'm not going to make these more complicated because, again, these are not super useful in the real world. We're going to get to real world applications of this in the next unit, but all the applications are going to involve natural logs. We're going to see that anything we could do with a log with another base, why bother? Let's just do it with a natural log. I do want you to get one final thing in your notes, just really all the formulas in one place, so you can see them all and realize the similarities and the differences. So the very last thing I want you to get, and I would highly recommend maybe when you get home, stick them on an index card or something. I know some of you are keeping like running lists of all the formulas I've been giving you. Make sure you're adding these to the list. The derivative of log base a of x, that's 1 over the natural log of a times 1 over x. Derivative of a to the x is the natural log of a times a to the x. The integral of a to the x dx is 1 over the natural log of a times a to the x plus a constant. I find these incredibly hard to remember because they're so similar, but they're not. And I truly think as far as your test goes, this is going to be just a sit down and straight memorization thing on these. I will tell you, we don't have time for a quiz on this stuff, but in the past I used to give a quiz on this section, and like most people ended up failing the quiz, not because the problems were hard, but because they didn't have the things in the right places. And of course, if you don't have the right formula, I can't give you much of anything here. I hope this made sense to those of you at home. I apologize for what happened today. I hope we'll be back online. Actually, it won't affect you guys at home Monday. It'll affect you people in front of me on Monday. I don't know.